OK, good afternoon, everybody. Welcome to the developer workshop of AWS. My name is Boaz Zinnemann. I'm a technical evangelist with AWS. And today I'm going to talk with you about how websites go serverless. And I want to start with a question. How many of you here in the audience are web developers? Nice. I should have taken a picture of that. OK, so I've been a web developer for 20 years, a bit more than that. And we've been doing websites in a certain way. And I want to talk about a new way to build websites using serverless technology. And before we talk about websites, let's talk a bit about serverless. What is serverless? So the basic idea of serverless is to allow you to build your application without dealing with the hardware, without dealing with the infrastructure at all. This will allow you to build better applications. This will allow you to invest more time in writing better code. And this is what we do. This is what we want to do. And the basic idea of serverless started with the evolution of servers. When we started with physical servers in data centers and then moved to virtualization, that changed a lot of the way we thought about hardware and how we utilize hardware. And then we moved to a virtual servers in the cloud with AWS, EC2, and other services. And eventually, we got to serverless when we are eliminating the need to run your own hardware. And when you're doing something like that, you don't need to deal with things like provisioning and utilization. You don't need to deal with availability and full tolerance and set your environment to be able to serve people from all around the world. You don't need to deal with scaling, which is a huge challenge, and everything around operation and management, like security patching and software updates, and making sure that your version is in line with the needs of your system and things like that. This is something you don't need to do anymore. And when you go with serverless, the first thing you're giving away is managing servers. And that's great. I never liked managing servers. And I manage many of them. The second thing is that you get flexible scaling. It doesn't matter if your application will run once a day or twice a day for some processing, back processing for finance, or it will serve customers that will have to scale according to the exact number of your customers. Then you're going to get high availability out of the box. We are taking care of distributing your application across multiple availability zones. So you don't need to care about deploying your application in those availability zones. And of course, you're not paying for idle. Today, when you're running servers and your usage of those servers, your utilization of those servers is below 50% or even below 70%, you're probably wasting money. And with serverless, you're paying only for what you do. And you're paying in increments of 100 milliseconds. So the cost of your environment is highly tied to the usage and to the number of users coming to your platform. Serverless applications are built with the next flow. There is an event source at one end, something that triggers your code. You will provide us your function, your code. This code can be in Node.js, in Python, in Java, C#, .NET Core 2.0, and Go. And we will trigger this code based on this event. And then you can run your code, access external services, pull data from databases, or anything you used to do with your regular backend code. And this is the basic idea of serverless. When we're talking about event sources, there can be plenty of different event sources. Like, for example, I'm doing a change in a database. Let's say I'm having a registration system that takes information from users and store it into a DynamoDB database, one of our database services, a NoSQL database. I can create a trigger that each time I have a new record, a new customer was added into the system, and I wrote a new line into the database, I will trigger a code that will take this information, put it into my CRM system, will send the customer an automated email with welcome and some instructions how to use the system, and so on and so forth. So actually, this operation of writing a record into a database is my trigger to run additional processes and additional processing. Another great example that we're actually going to use it later today with a demo I'm going to do, this is why the camera is here, is storing a file into S3. S3 is our object storage, and I can trigger a Lambda function each time I'm storing a new file. And I can do whatever I want with this file. I can take an image and process it into thumbnails. I can change its size to adjust it to different types of media. Or I can take a text file and mail it to somebody just as a result of somebody putting this file into a specific bucket. And there is a very long list of triggers for Lambda. We're going to talk about several others today and show some of them. So let's talk a bit about website architecture. So many of you are web developers, so you probably saw this drawing at least once before, right? So most web applications are 3 tiers applications. There is the presentation tier, when all my HTML files and media files are there. There is the logic tier, which is usually my backend running on web servers. And there is the data tier with my databases. Simple, right? So in real life, not really. When you're translating this simple 3-layer application into real life, you're starting to see that you need to take care of a lot of things to make sure your application is running and performing well. So you have components like managing DNS and managing CDN services. You have load balancers to make sure that your web layer can scale according to the number of users. And then you have another load balancer that will scale your backend layer, and databases and replication for those databases. And a lot of work I need to put into a system to make sure it's performing well, it's providing the service I need, it's fully secured, it's backed up, and many other things. There is a lot of work that I used to do as a web developer to make sure my application is running and performing well. And sometimes it didn't. And this is one of the biggest challenges. So how websites can go serverless? Can we have a serverless website? A website that is serving customers can be a website, it can be a web app. Actually, what I'm talking here about web applications is relevant for mobile applications as well and for any other applications. But can we have something that will serve customers without dealing with servers at all? And obviously, the answer is yes. This is why I'm here. So let's look at this web application. So I have here a web application that is running with no servers whatsoever. And we have all 3 tiers into this architecture. And let's talk about the top ones. Let's talk about our static content, our presentation layer. So here at the top, I have Amazon S3 and Amazon CloudFront that will serving your static websites. If you don't know at this stage that S3, our storage, can serve static websites, you should look into this straight after this session, because this is the simplest, easiest, and cheapest way to host static websites. You're just putting your HTML structure with the index files and your JS and CSS and images and media files into an S3 bucket, defining it as a public bucket with an HTTP endpoint, and you can browse it as if it's running on a web server. You can even put your own domain name on this bucket, and here you go. You have a static website with no servers, no infrastructure whatsoever. And Amazon CloudFront, connected to an S3 bucket, will provide you the CDN layer that will allow you to distribute this website all over the world and put the content in front of the users physically very close to them, which will increase performance and will give you some additional benefits that I'm going to talk about them in a second. So this is my static layer. So what about my backend? What about my business logic? So you can implement business logic today with no servers using Lambda and using Amazon API Gateway. So if I have my static website, and this static website is accessing my backend using JavaScript, using API calls to Amazon API Gateway, I can move my entire logic into Lambda without running servers. So for example, if I have on my static website a registration form, and this registration form, when I submit it, the action is basically a JavaScript call, a JSON call with this information into API Gateway. API Gateway will send this information into a Lambda that will store this information into DynamoDB. And this is how I implement some business logic without any backend. And going into this setup brings a lot of advantages. And I don't need to deal with anything related to running the physical infrastructure and the software infrastructure for my web server. And another thing that is really missing here is user management. And even user management you can get today with a tool called Amazon Cognito that will manage your users. And I'm going to go slightly deeper into Amazon Cognito in 1 or 2 slides. But if you need to write a system now that registers users, manage them, even sending them the confirmation and activation email straight from the system, you can do it in 5 minutes by setting Amazon Cognito and forgetting about everything you've been doing with user management as a very, very simple service. So this is a very basic illustration and a very basic setup. Let's talk a bit about security. How do I secure something like that? So each one of those components has its own security features. If I'm looking at S3 buckets, I can use bucket policies and ACLs to define my buckets according to my exact needs. I can have buckets that are completely public. People can access them with a very simple URL. And this is for my images, my website, anything like that. I can have buckets that are completely secured, and only customers with specific credentials can access. It can be customers, users of your website. You can allow them access to areas for registered users and other areas for unregistered users. And it can be your admins that might upload content, upload images, or anything like that. So this is the part of setting your permissions for your S3 bucket. Amazon CloudFront will give you a lot of security features, like checking the location of your users and using geo-restrictions. So if you have to provide different type of content or restrict access to content based on location of the user, you can do it with CloudFront. Super popular in the media industry when you can access specific videos if you're in one place of the world and you can't do it if you're somewhere else. You can do signed cookies and signed URLs. So if you want to provide content for specific users with specific URLs, you can create a URL that is going to be alive for 24 hours, and after that, it will expire. So you can sell digital assets, digital content, by using something like that, and you're getting DDoS protection out of the box. And of course, you can install SSL and have an HTTPS-based website with CloudFront in a click of a button. So if 10 years ago, or even 5 years ago, when I was trying to figure out should I do SSL or should I not do SSL, so 10 years ago it was no, we're not doing SSL, it's too heavy, it's too expensive, it takes a lot of time, a lot of effort to manage your keys. I'm going to do SSL only for the real secure content, user information, stuff like that. Everything else, we just do plain HTTP. Today, you can enable HTTPS on your website in a click of a button. And there is really no reason for you to create an unsecure website. So take it into account. So this was on my front end. What about my back end? So at the back end, I'm using an AWS tool called IAM, Identity Management, and I can provide a role for each one of my components. And those roles will tell the system who can do what on the system and which type of information one component can access from another one. For example, my Lambda function. Remember the use case of registering a user? Okay? So I have a Lambda function that takes information from my website and writing it into a database. I can define a role that will allow this Lambda function to write data to a specific table and only to write. And have another Lambda with read permissions to this specific table or to multiple tables. And I can really fine-grain my security schema on this application very, very easily using IAM roles. On the API gateway, I'm getting a lot of added value by some features of API gateway, like throttling. I can set throttling on my API and make sure that customers won't abuse my API from one end. From another end, if I'm connecting my API into a legacy system, there is a very important thing you should know about legacy systems, and that their ability to scale is very, very limited. One of the ways to make sure that your legacy system won't crash because of a lot of traffic coming for users is using throttling on your API level. Another thing you can do, you can have caching to make sure that not every call will trigger a Lambda. You can have usage plans. So I can sell my API to different users with usage plans. I can have a user that has 1,000 requests per second, and another user that is paying twice that much with 10,000 requests per second on my API level, and API Gateway will basically enforce this policy. I can put my SSL keys and make my APIs running on HTTPS using Amazon ACM, the certification manager, and create my own keys. So this is security-wise. You have a lot of options to secure your website, something that when we were dealing with servers and hardware, we had to invest a lot to get the same level of security. And we were speaking about users. So I want to go back to Amazon Cognito and talk about managing users and providing credentials for users on top of AWS when running serverless websites. So when you're accessing your API gateway, in many cases, you would like people to access your API gateway with specific credentials. And you can manage those specific credentials with Cognito and with some other options and some other tools. So one way is to do custom authorizers using Cognito user pool. You're basically creating a user pool, registering your users into this pool. We will support everything needed to register those users, including verification, email, and user management. And each time there is an API request, API Gateway will check against Amazon Cognito if the user is authorized to access this API or not. If you need to create your own authorizer, I don't know what the reason for that, but there are some use cases that you need to create your own authorizer. You can use Amazon Lambda to run your own custom authorizers. You can connect Cognito to OpenAD and to third-party user management systems like Facebook, Twitter, Google, and others. So you can manage users that already have account on these systems. And you can send this information in two ways. You can have token only. So there is a token generated by Cognito, and the system is taking the token, comparing it against what's in the request, and can now decide if the user can access the information or not. You can have the full request with all the headers and then make a bit more complex decisions regarding if the customer can access something like that, this specific request, or you should drop it and not allow access for this thing. Another great thing you can do today is have multi-region deployment of your application. And I'm not talking about multi-availability zones. Multi-availability zones you're getting out of the box. I'm talking about real multi-region. I have an application here that is deployed on US East 1. This is in the US. And on EU West 1, which is in Ireland. And I can have 5 more like this in different regions that AWS provide. And when your customers will ask to access the information, they will go to Amazon Route 53, which is our DNS service. Route 53 will calculate the best performing endpoint according to the location of your customer, and will return a specific CNAME for your application that is closest to the user. And then when the user will make his call, he will access his regional API gateway and not a single global one. What you can get out of it is 2 very important things. First of all, performance. If the API is closer to the user physically, usually the performance is much better, the network latency is shorter. Another thing, you can have different versions of your API based on location. So I can have one service for my European customers and another service which is slightly different for my American customers, and a third one for my Asian customers, and so on and so forth, by using something like that. So as you can see, a lot of options to create your serverless website. And if you think this is something we're just talking about and it's very, very complex, try this thing. I have 2 links here for both the blog post and the Git repo of somebody that built a complete online store serverless, including the shopping cart, and including the user management, and including the fulfillment and everything else, without defining and without building any servers. So this is just one example, but I want to play with something I created for this session and show you a little demo. If you want to join the demo, I'm going to show you the website in a second. Everything I'm showing here is available on GitHub so you can download the code later and try to deploy it yourself. Let's play a bit. Where am I? Not working. It's going to be tricky. I'll move it here. OK, say hi. Let's make it slightly bigger. OK. Yeah, you're live. It's working. So I have an application here you can access if you want from your mobile phones as well. It's called record.zinnemann.com. It's basically a website to take pictures and run AI recognition on those pictures automatically. And we're going to play a bit with this application. So let's start with this camera. And I'll try to take a picture, although I'm working with this screen. It's really, really annoying. Look at this camera. Be nice. Smile. Let's capture a photo. Let's upload it to S3. And let's see what recognition can tell me about this photo. OK, so I see people, person, footwear. Who has footwear? And some other things. And basically, I just created the flow that is taking a picture from my camera and uploading it into S3 and analyzing the picture automatically. Let's do one more picture and do a selfie for my phone, because it's going to be really, really nice. Wait a second. Say hi. Say hi. I'll upload it in a second. OK, done. And now let's see what else do we have here. So as you can see, this is a display for a single image with all the tags that the system can see in this tag. I can click on a tag and get the tag page, basically all tags with person. Thank you for taking pictures and uploading them. I see that you're using it. I can go to my gallery and I have all the pictures that have been uploaded. Cool. I hope people from Twitch are uploading pictures as well. This looks like something coming from Twitch. And as you can see, I have several scenarios here that basically are using this image, uploading to my website. Let's talk a bit what's happening behind the scenes. This is really, really tricky. Other side. My mouse. OK. So I have a serverless website. And this website, I have users that are going to CloudFront with my domain. And CloudFront will send them to a static site bucket on S3 that includes all my index HTML and my different pages, style sheets, JavaScripts, images, anything that I need to construct the website. Then I'm using Amazon Cognito and assigning a role to this web page. I'm using an unauthorized role. So basically, there is no authorization in my application. Everybody getting the same role. And when I getting this role, I hope you can see at the bottom of the screen, basically this role will allow the user to do several things. It allow the application to write images into the images bucket. This is this one, not the one that is including the static website. This is my images bucket. It will allow me to read the list of images from the same bucket. And it will allow me to read that data coming from DynamoDB. I'll explain in a second why do I need that. So this is my initial flow. This is what you get when you're getting to the home page. There is nothing there that is dynamic. At this stage, everything is static. Everything is implemented with HTML, JavaScript, and CSS. Then when I want to upload an image, I'm going to the next flow. And basically, with the JavaScript SDK running inside my browser, I'm uploading an image into my images bucket. If you remember from the previous stage, I got credentials and got permissions to do that for my role attached to the Cognito profile. Then, after the image is uploaded, there is an automatic trigger triggering a Lambda function. And this Lambda function is my code. This is actually what's happening behind the scenes. And it's fully automated. And this Lambda function has its own role. And this Lambda function will be able to read the image from the images bucket, to execute recognition, which is part of our AI services, execute two API calls. One is detect moderation labels. So in case you want to upload some unsafe content, I will delete it, and it will do it automatically. And execute recognition detect labels to provide me the list of labels. And the last thing it will be able to do is to write into DynamoDB all the labels that were returned from recognition. It will execute recognition, and eventually will write all the tags coming from recognition into DynamoDB. OK? And then, if I want to go and query a single image and ask for tags inside this image, the same SDK with the role I have from Cognito, because I allowed to read data from DynamoDB, I'll be able to go directly into my DynamoDB. Don't do it at home. This is not really a safe way to access a database, but wanted to make a point. I can go directly into Amazon DynamoDB, query it, and provide you information regarding specific image. If I want to do something in much larger scale, I'm going to add API gateway into the game. So for my gallery page or for my tags page, what I do is basically sending a request into Amazon API gateway that I would like to get a list of images for a specific tag. This will trigger a Lambda function, another one, not the one from the previous stage, that will read the information from DynamoDB based on my tag, query the database, and return the information back to Lambda function. Lambda function will return the information in JSON format into Amazon API gateway. And at the end of the day, I'm going to get a list in JSON that I can parse with JavaScript and basically display the images on my website. And as you can see, end-to-end, no servers whatsoever, and everything here is based on services. So we're talking a lot about Lambda. And Lambda is our implementation for serverless functions. But you have to remember, when you're building serverless applications, you're using more than one service. It's usually not only Lambda, and it usually includes many other services, like in this case, recognition, DynamoDB, S3, API gateway, and many, many others. And if we're looking behind the scenes, it's going to be really, really challenging to do it, yeah, as I thought. Let's try to send my There you go. And if you're looking behind the scenes into my code structure, into my code setup, I'll increase the font a bit. So you can see this is my project. And if you're looking into the section of the static website, this is a static website that we used to have. It has my index file and all my other HTML files. And it has my CSS folder and JavaScript folder and images folder and everything like that. And I have my Lambda section in another part. As I said before, you can get all of this from GitHub and play it yourself. The nice thing about this application and this deployment, that this deployment is fully managed by a framework called Serverless Framework. So when you're doing serverless applications and you're starting with it, usually you start with a very basic setup. You're just writing your functions and managing them one by one. And after a week or two or a month or two, you're finding yourself managing 50, 60, 600 functions without any infrastructure. So if you're going to create serverless projects, I really encourage you to select some kind of a framework that you can use to manage your applications. In this specific case, I'm using Serverless Framework. You can use SAM, which is a framework we provide, and there are many, many others. Just choose the one that works best for you. Doesn't really matter, as long as you make sure that you're managing those applications. Why do I need those frameworks? I need those frameworks to define my application. My configuration file, this serverless YAML, is basically defining everything that I have inside my application. I'm going to scroll really, really fast. We're not going to stop in specific places. But everything you saw on my diagrams before, those DynamoDB databases and the S3 buckets and all the security credentials and who can read and who can write and my functions and my triggers, everything is defined here. And if I need to make a change or add another function, I can do it with this setup without doing it manually and then trying to remember what I did yesterday. And this is fully managed with version control in GitHub, so you can look at your infrastructure, the infrastructure running your function, same way you're looking at code. And this is how you should do that. Just one thing that, that we can look at. So for example, I have the resource section, and this is my definition for my DynamoDB tables. And as you can see, I'm defining my attributes and my keys, and even my provision throughput for DynamoDB. And I can play with it. And just before going on stage, I changed my provision throughput for one of the tables, not this one, because it's not getting a lot of traffic, but for this one. Where is it? I don't see it. Oh, yeah. So this one is the one that is creating the indexes and the gallery page. So I figure out that it's going to be some traffic on my application. So instead of giving it a throughput of 1, I increased the read capacity to 5, saved it, deployed it. It takes a few seconds, and I have a new version up and running of my application with new parameters as my setup. And you can basically decide exactly how do you like to do that. On my AWS side, if you haven't seen the Lambda console yet, so this is my Lambda console. This is the end result of my deployment. And as you can see, this is my definition, the trigger. This is the function that runs recognition on the new images I upload. You can see that I defined the trigger to be S3. And this is all my credentials. It can go and access my logs. It can read from DynamoDB, write to DynamoDB, execute recognition, and read data from S3. And this is the function itself. Where's my code? I can't show it to you here, but I can definitely show it to you over here. So as you can see, in total, 108 lines of code to run the entire process of getting the image, executing recognition, storing the information, and super simple, everything using services and APIs. Of course, there are other parts of the application. There is my S3 bucket and my API gateway, and everything is defined in one place, and I can control it very, very easily with the different tools. OK. So this is my serverless website. Feel free to play with it. Feel free to go to GitHub, download the code. There are instructions on GitHub exactly what you need to change to make it yours, because it won't run with my domain and won't run with my credentials. So make sure you're doing the right changes when you're deploying it on top of your application. But this is how you create a serverless website. And I was showing you here several options to connect between your front-end application and your back-end. In this specific case, we use the API gateway, and we use the JavaScript SDK to connect directly into your services. But obviously, there are many other tools you can use from AWS. We talked about AppSync in the previous session. You can definitely integrate AppSync into something like that. I even have a demo that I think I'm doing tomorrow using AWS IoT as the backend of a chat application in the browser. And I'm using AWS IoT because it's really easy to work with WebSockets in AWS IoT. So there are a lot of other options you can integrate with different AWS tools and create your own application. And the only thing that I want to say is, what are you going to build with that? And this is your challenge. So this is what I want to talk about. Are there any questions that you would like to ask after this session? Do we have a mic? I have one here. Can you pass the mic? Thank you. Over there. Wait, we can't hear you. It's over here. Over here? Not working? Yeah, it's working.
Yeah, it's working. Okay.
Thank you.
So probably this is a stupid question, but whatever. Is it possible, would it be possible to also split an already built application or something like a framework or something that needs a server in order to be used like serverless? Like, for example, PHP frameworks built in Laravel or something in Ruby on Rails. Is it possible?
So right now we're not supporting PHP for Lambda, so this is one issue. But you can overcome this by bringing your own, basically your own binary. Not that I recommend to do that. But in theory, you can integrate into your code, like in Java or in JavaScript, you can integrate your own libraries into Lambda and then use them. And this is one way to do it. Another way to do it is to split your application, to keep some of your application to run serverless because it makes sense to run in serverless, and other parts run as you used to do. If you have something like video processing that is not really suited for something like Lambda, I would probably still keep my servers and run them for video processing with any framework that I need, with any tools that I need, and have this user front end and management and everything else run as serverless. So you have both options. In terms of languages we do support, you can bring your own libraries into the languages. Okay.
Thank you.
Question over there? Yeah.
Hi. I really like the...
Can you speak up? I can hardly hear you.
I really like the whole architecture of using serverless for simple websites. And I've done that a little myself. But one challenge I had is, can I require user login for a static S3 hosted website?
Yeah, so I was saying that I'm loading credentials for unauthenticated users. You have the same process to do for authenticated users, and you're just putting the authentication page, your logging page in front of that, and then getting a different set of credentials for those authenticated users. And you can decide that this S3 bucket you can allow access to it only for authenticated users.
So I would make a public bucket with a login HTML, and then when they log in, they would get access to a private bucket.
The login will go to Cognito, will check the credentials, return a token for this specific user, and then with this token, you can actually go to the next stage.
OK, thank you.
Any more questions? OK, thank you very much for coming. We still have one session for today about containers, and we have a full agenda both tomorrow and on Thursday that you are more than welcome to join us. If you haven't scanned your badge yet, please do that. We're going to send the developer workshop slides and give you $200 AWS credit if you scan your badge. Thank you very much.